Good day everybody, we are expected to solve these two equations. Now this is a sphere and this is a plane. Now we can use geometry to solve, but I will be using algebra to solve and find the value of x, y and z. So foremost, let me take this as 1 and 2 and I will consider the equation, or I would say, let me use this identity. Which is x positive y positive z, the whole square. Okay, I hope you are able to watch. This is going to be x squared positive y squared positive z squared positive 2 times of xy positive yz positive zx. This is a famous trigonometric identity. Now x positive y positive z is 12. So this is going to be 12 squared, and x squared positive y squared positive z squared, this is 48. So plus 2 times of xy positive yz positive zx. Move this to the other side, you get 144 negative 48 is equal to 2 times of xy positive yz positive zx. Now from 144 you take 48 out. This will give you 6 and 13. From 13 you take away 4, you get 9. So 96 is equal to 2 times of xy positive yz positive zx. You divide both sides by 2, you get 4 and 8. Right. So 2 gets cancelled. So 48 is equal to xy positive yz positive zx. So this is another system you have. I can rewrite this as xy positive yz positive zx is equal to 48. Let me take it as sum 3. Now what I wish to do is I want to perform a subtraction between 3 and 1. Okay, 1 minus 3. So what is 1? X squared positive y squared positive z squared, and I'm subtracting x, y positive yz positive zx. On the right hand side, 48 minus 48. So this is going to be equal to 0. So you have x squared positive y squared positive z squared negative of xy positive yz positive zx is equal to 0. Now can I write this entire system? Can I write it as, say, for this first term, x squared and negative xy, can I write this as x negative y the whole squared? If I were to square it, I get x squared positive y squared minus 2 times xy. Right. So x squared is there, y squared is there, but negative 2 times xy comes where negative xy has to come. So there is an addition of 1 xy that we have to remove. Or what we can do is we can create a system so that we need to have a product multiple. If we can product multiple the entire system by 1 over 2, then this will give us the original system. So that is the idea. So what I'm going to do is I'm going to rewrite this entire system as x negative y the whole squared plus y negative z the whole squared. So there are 2 y squareds coming, so I need to get rid of 1 y squared. So that is where the multiplying the quantity by 1 over 2 comes into place. So similarly this is going to be z negative x the whole squared. So if I were to expand this, I would get 2 times x squared, 2 times y squared, 2 times z squared, 2 times xy, 2 times yz, 2 times zx with the appropriate negative signs. So we need to have a 1 over 2 there. So this entire system is this multiplied with 1 over 2 is equal to 0. Now if you cross multiply 2 you get x negative y the whole square positive y negative z the whole square positive z negative x the whole square is equal to 0. Now look at here. This is a perfect square, this is a perfect square, this is a perfect square. All of these perfect squares are being added, and that has to produce u 0. Is it conventionally possible? The only time that this can be possible is when x negative y is equal to 0, y negative z is equal to 0, and z negative x is equal to 0. In other words, what I'm trying to say, x negative y squared should produce me 0, y negative z squared should produce me 0, z negative x squared should produce me 0. And that is only possible if x negative y is equal to 0, y negative z is equal to 0, and z negative x is equal to 0. So what does this mean? This means from here I can directly state x is equal to y. From here I can state y is equal to z. From here I can state z is equal to x. So this is cyclic in nature. X is equal to y, y is equal to z. Right? So what is the meaning of this? This means the solution is x is equal to y, y is equal to z. So if x is equal to y and y is equal to z, therefore I can write 2. 2 is this. Right? x positive x is equal to 12, which means 3x is equal to 12, which means x is equal to 12 divided by 3, which means x is equal to 4. So x is equal to 4 is the solution. Not only that, x is equal to 4 is a solution, y is equal to 4 is a solution, z is equal to 4 is a solution. So that means the plane and the sphere, they meet at the point 4, 4, 4. That is understanding. This is geometrically explained with the conclusion alone. Of course, we have not done the entire geometry part of it. The conclusion is 4, 4, 4 is the point of contact, but that is secondary here. What is algebraically acceptable here is this conclusion: x is equal to 4, y is equal to 4, z is equal to 4, because that is how we handle the problem, right? We looked at the problem from the algebraic standpoint, not from the geometrical standpoint. So geometrically, this is the added point that I am giving you for your own understanding. So the problem solution stops right over here. Thank you everybody. Please like, share and subscribe.